Alright, we'll do a review here. Hopefully, my voice is okay. Alright, let's go. Okay, I think we have only 20 questions here on this review sheet, which is not much. Alright, the first section we go over those definitions that we had for the first chapter. Okay, so for example, number one, identify population and sample. So as we mentioned, the population is the whole idea. Okay, sample is a part or a subset of a population. So in this case, we have population as all American household. Oh, it's like all American households, and then sample will be the 1094 American households that are being surveyed. Okay. So population is the whole idea, sample is a part or a subset. Okay, same thing here for the second question. Elementary school children will be the population, all elementary school children, and the 2,625 elementary school children will be the sample. All right, moving on. Next question, number 3. Parameter or statistic. Parameter describes a population characteristic and a statistic describes a sample. All right, so in the question it said in a recent survey, if you see the word recent survey, you know it's something about the sample. Okay, something about the sample. So what's the survey is about? So the average salary of this many graduates out of this many graduates was this much money. Okay, so I think this would be the population because the total graduates and the 10,500 would be the sample. Okay, so here this is a numerical value. This value, since comes from the sample or describes the sample, this will be a statistic. So if you see a recent survey, you know it's something related to sample. Okay. Move on, next one. You see all employees at certain car manufacturer. All employees, this word give you the idea of being population, right? Population. Okay, so this number will be a parameter. There we go. So if you can identify population and the sample, we should be able to know about parameter or statistic. Okay, move on. Number 5, girls soccer team number on t-shirts. Okay. Numbers on t-shirts of soccer team. We go over those ideas about when numbers can be labels, like the t-shirt number, ID number, social security number, what else? Phone number, all student ID number. All those numbers, even though they are numbers, but they do not have numerical meaning. Those are just simply labels. Same goes here. It should be B because the girl t-shirts number definitely has no numerical meaning in this case. Okay, this one, number of complaint letters received by U.S. Post Office, that will be a quantitative. That has numerical meaning for sure. Level of measurements. Number 7, we go through that already. It should be nominal because, come on, it shirts number, right? Number 8, age should be ratio. Age should be ratio. Okay. Temperature will be a interval. Final grade will be a ordinal. Annual salary will also be ratio. So here we have age and money. Those are ratio level. Or you can give yourself very simple example to express age and salary in terms of one as multiple as another. So for example, age, one is 30 years old, the other is 20 years old, 20 is twice the age. Okay. Salary, if someone's making 40,000, someone's making 80,000, this is twice the money, twice the age. So it's expressing one as multiple as the other. Okay, that's typical ratio level. All right, A, B, C, D, F, I think we're okay with ordinal because we preferred A, right? So the order matters. However, there's no number involved. We cannot move on to interval or ratio level. So we settle with ordinal. For temperature, should I go for temperature again? I've used temperature like 10 times. Typical interval level, right? 0 is a position on the scale. 0 representing 0 degree does not mean none. Okay, that's about the 4 levels of measurement. If you still have trouble here, go back to the lecture recording on this section. Okay, move on. All right, this question is a very long question here. I'll roughly go through it. I'm not gonna do all the graphs. It's gonna take hours probably to finish all the graphs here. However, I will try to finish the frequency distribution here. Okay. Okay, let's see what we do. One thing I forgot to mention though. Oh, I did mention. Great. Okay, did I change this number to 5? I totally forget. Let me find out. Maybe just keep it at 6. It's fine. Let's do the frequency distribution first. All right, in order to have a frequency distribution, okay, first we will have a class width. We will have a class width. Class width, in definition, it will be the difference between two consecutive lower or upper limits. Okay, that will be class width, like how wide a class is. But in order to find it, we like to use range divided by the number of classes. Range over number of classes. Okay, let's find range here. Range is what? What's the biggest number? Maximum minus minimum. Oh my, I see a 50. Anything bigger than 50? Nope. 50 is the maximum. How about minimum? I see a 33. That's small enough, right? Yep, I'm actually doing it right now, so cloth width will be the maximum, which is 50. Take away the minimum and divide by 6. Okay, so I have 17 over 6. Let me see how to. 17 divided by 6 is 2.83333, all rounded by 3. Remember, we round up to the next convenient number, round it up. So we have a class width of 3. Now let me have my table ready. Here we have class limits. Yeah, we like to start with the minimum, which is 33. Okay, then we'll add class width to find next lower limit. I will stop at 6 classes. All right, and find the number next to the next lower limit. to define as the upper limit. So this is a 36, which means the next number before should be 35, 38, 41, 44, 47, 47 plus 3, I have a 50. Okay, there we go. We have the class limits ready. Next, since we have a frequency distribution, we need the frequencies, right? We need the frequencies. How do I do that? How many numbers I have? 30 numbers. Okay. Let me try that way. Okay, I'll do tally marks now. I'll do tally marks to mark all the numbers. 44, 38, excuse me, 41, 50, 36, 36, 43, 42, 49, 48, 35, 40, 37. If you know it already, you can skip ahead. 50, 45, 45, 39, 38, 50, 41, 47, 36, 35, 40, 42, 43, 48, and 33. I have 3, 6, 6, 6, 3, 6. Okay, and if I take the sum of all the frequencies we have for 6 and 2 2s will be 30. Means I'm not missing or overcounting any number. That's great. This is my frequency column. Beyond frequency, we have class limits and frequency. We like to have midpoint. Okay, we have the relative frequencies. We like to have the cumulative frequencies along with class boundaries. Okay, to find midpoint, to find the midpoint, we like to use lower limit plus the upper limit and divide by 2. Okay, so I have 33 plus 35 over 2. That will be a 34. Okay, just repeat the process. We have all the midpoints. For relative frequency, we would like to use frequency over the total frequency. So for our case, we have 3 over 30, that is a 0.1. And 6 over 30, a 0.2, 0.2, 0.2, 0.1, 0.2. Okay, cumulative frequency, we use the frequency add up all previous frequencies. So the first will be 3, the second will be 3 plus 6, that's a 9. And then the third one will be 6 plus 6 plus 3, so add another 6, that's a 15. Add another 6, 21, add a 3, and then add a 6. See, this number do match the sample size. Okay, lastly, for boundaries, okay, the formula where the frequency is the frequency over the total frequency. Okay, for boundaries, we take away 0.5 from the lower limit. We add a 0.5 from the upper limit to stretch it wider interval. Okay, so I have 32.5 to 35.5. Okay, and then 35.5 to 38.5, 38.5 to 41.5, 41.5 to 44.5, 44.5 to 47.5, and lastly 47.5 to 50.5. Alrighty. As I mentioned, I'm not gonna do all the graphs here. Okay, the graphs take longer times for me to do because I need to have the, I don't know, the scale and everything. Okay. However, we did go over all the graphs in class. If you'd like to review those graphing, you can go back to the lecture. Or you can just graph on paper, and if you want to ask me something, feel free to email me. Okay, that's about the graph. Now, stem and leaf. Stem and leaf and dot plot. Okay, let's talk about those two. Okay, for stem and leaf, we'd like to take a number and to separate the number, and let's say this is my key. So for a bar 4 is 44. That's how I gonna make my stem and leaf graph. Okay, and then I will have a line. Okay, that's I'm gonna separate the stem and the leaves, and on the left will be my stem. Our stem will be starting 30s to the 40s and then up to the 50s. Okay, and I'm just gonna add the leaves, add all the leaves on the right side in order. In order, you don't want your leaves to big, small, like jumping all over the place. You want it from small one to big one in order. Okay, that's stem leaf. Over this one, that's fine. There we go. We have the frequency distribution. The whole table is ready. Okay, and the stem leaf, that's how we do stem leaf. Move on. Okay, number 15. Find mean median mode. Mean median mode. What to do? For mean, we always sum all the x's and over n, right? It depends on what we're dealing with. If we're dealing with a population, we will write to the mu is the sum of x over n. Or we can have x bar is the sum of x's over small n as the sample mean. So let's do a calculation. Scores top 10 finisher. Let's call it population. Okay, we'll add up 71, 67, all the numbers, including last 72s, and we have top 10 because we have 10 number. Let me calculate it. 71 plus 67 plus 67 plus 72 plus 76 plus 72, 73, 68, 72, 72, and then divide by 10, I have 71. Okay, this is a good example that you need to bring your calculator. Okay, you need it. Otherwise, how do you gonna plan to add up all the number? Gonna take you a big chunk of time. Oh, this is not a phone. Calculator. Okay, bring calculator. There we go. We have the mean at 71. Now for median, we cannot just choose the middle two and then we say median is 74. It doesn't work like that, right? First, order. You always need to order for you to do the median. So I'll order from 67, 67, 68. Okay, now on to 71, 72, 72, 72, 72, 73, and 76. So that's the numbers ready. Now the middle two number, because we have even numbers, right? So median will be 72 plus 72 divided by 2. That's also a 72. Median is 72. Okay, mode, which gonna be which number repeat the most. Apparently, we have 72 4 times. That would be our mode. Okay, that's all follow-on question about mean, median, and mode. I'm hoping everybody have full credits on those questions. Next one, weighted mean. Weighted mean formula, let me put it down here first. That's our weighted mean formula. Let's see what's the situation here for the students. Okay. Let me mark X and W. A student received test score of 60, 85, 95. Those are test scores. Okay. And final, he got 86. Homework is 78. Okay. Now let's see the weight. Each test was 20%. We have 3 test scores, that's 20%. And the final is 30%. And the homework grade is 10%. Okay, in decimal. I like decimal better in terms of calculation. Take the sum of the weight, that is 1. Okay, I'm making sure I'm doing something right here, that is 1. Now, to calculate it, we need X times W, which is right here, inside the parentheses. Okay, do that. 12 was 85 times 0.2, 17. 19. If I'm wrong, check me. What is 86 times 3? Okay, X times the weight. And then we need to, here, take the sum, right? The sum will be 12 plus 17 plus 19 plus 25.8 plus 7.8. I have 81.6. That's the sum. So my X bar will be 81.6 divided by 1. That is 81.6. So this is the student's average score for this course. Okay, moving on. Mean for frequency distribution, or mean for the grouped data. Same thing. Sum of X times the frequency over the total frequency. Sum of X times the frequency over the total frequency. Here, inside this formula, we have an X. Okay, X is what? X is midpoint for each class. So let's find that first. We mark X. Midpoint for 2 and 4, we will use 2 plus 4 over 2, that is a 3. Okay, 5 to 7, the midpoint gonna be 6, right? 5, 6, 7. Otherwise, if it's hard to find, we will use 5 plus 7 over 2, 8 plus 10 over 2 to have the next one. Okay, those are the midpoints, and we have the frequencies. We're ready to move on to, in the parentheses, we have X times the frequency. X times the frequency. Okay, what's 6 times 12? We have the frequency multiplied by every data value. Now let's take the sums. We need the sums of the frequency and the sum of X times the frequency. Sum of the frequency is 35. No, 24 plus 72 plus 81 plus 90. I have 267 as the sum of the product of F and X. So the average, the X bar, the mean for this frequency distribution, we use 267 divided by 35. So it's 7.6. 2857 and so on, so I rounded by 7.63. So now we know for this frequency distribution, the average is 7 point something. That will be the average for it. Okay, move on. Okay, population standard deviation, population variance. Okay, well, this is the last section that we learned. All those have the same numbers, the 70s? No, just curious. Okay, let's do that. In order to find population variance and standard deviation, first let me list the formula. So sigma square is the sum of x minus mu square, okay, over n. The sum of x minus mu square over n, which means we need to know what mu is, right? That we brought sigma is the square root of sigma square. That's no problem. However, we need mean first. We need mean to, put into the formula to do the calculation. So mu is the sum of x over n. Okay, we're gonna add up all the numbers and divide by 10. Let me calculate that again. 70 plus 72 plus 71 plus 70 plus 69 plus 73 plus 69 plus 68 plus 70 plus 71. I have 703. They want us to they want us to round mean as a whole number, right? Which is wonderful. So that calculation will be easy. Now we have the mean. Okay. So for this table, I have a list for all the x's. Okay, and according to the formula, we need to calculate difference of x and mu. So this is called what? X minus mu is the deviation, right? Deviation. And use every number to take away 70. X minus 70, because 70 is the mean, which is right here. 70 is the mean. Okay, every number take away 70 to find out distance between every number and the mean. And then we like to square that. See here, we like to square every number to avoid 0. If you remember that we did calculate the sum of deviation multiplied 0. Okay, now we need the sum of the squares. The sum of the squares. There's a 5, 10, 5, 21. Let me know if it's not right. The sum of the squares, I have 21. So now we can have our conclusion that sigma square, which is the population variance, is 21 divided by 10. We have 10 numbers, so it's 2.1. That's our population variance. Okay, for standard deviation, we're gonna take a square root of 2.1. Let me see. 2.1 square root. I have 1.449 something. That's fine. Okay. 1.449 or 1.45. That will be the standard deviation for this example. Okay, so population variance and population standard deviation. Moving on. Next one. We have 30 students list here, and good things is this is already ordered, not your example in class or in your exam always going to be ordered. Maybe, maybe not. So pay attention to that. Now find the 5-number summary. Okay, and then find the interquartile range. Have the box whisker plot. Outliers is the full package. Percentile correspond to 63, 25th percentile. Let's do it one by one. Okay, let's find the 5-number summary first. The 5-number summary will be the minimum, Q1, Q2, Q3, and then the maximum. So minimum will be 31, maximum gonna be 99. If you don't know how to find the three quantiles, those are the information you can give. Those are points, right? Just don't skip. And then we'll start with the middle to have Q2. That's 70 plus 74 divided by 2. So that should be a 72. Okay. And let's cut the order data set into two halves. Okay, so the first half is from 31 all the way up to 70. The second half is 74 up to 99. Okay, for the first half, we actually have 15 numbers. I think the 58 should be right in the middle. Let's check. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Good. For the second half, 83 will be right in the middle. So we have we have the other two medians ready. So we have the three quartiles. Here goes the 5-number summary. Now, interquartile range is Q3 minus Q1. So we have 83, take away 58, whatever that is, 25. The 25. So interquartile range will be 25. If I ask you range, because the position, sometimes I mix things together, that will be maximum minus minimum. So it will be 68. Okay, interquartile range and range. Now the box whisker plot, let me put it on top here. Box whisker plot, one thing first, we like to have a horizontal scale that covers the range for the whole data set. So let me start with 30, 40, 50, 60, 70, 80, 90. Is that enough? No. 100. That's enough, right? Cover the range for the whole data set so that I can put points above it. And then I'll place the 5-number summary above this axis. So have Q1 as 31. That's the minimum. Or I can mark minimum. It's all fine. Sorry, what am I saying? Minimum is 31. Q1 is 58. Q2 is 72. Q3 83. Maximum 99. Okay, for box whisker plot, we like to draw a box from Q1 to Q3 that represent the middle 50% of the data. Okay, and we have a vertical go through Q2 that represent the median, and then all the way from the first to last dot to connect all the dots. That's our box whisker plot. Okay. Now, next section. Okay. Separation. Outliers. 25 outlier on the small end, we have Q1 take away 1.5 times IQR. On the bigger part, we have Q3 add up 1.5 times IQR. Okay, so any number that is smaller than Q1 minus 1.5 times IQR, that will be an outlier. Same goes on the bigger side. Any number that is greater than Q3 plus 1.5 times IQR, that will be outlier on the bigger end. Okay, so let's calculate those numbers. Q1, let me not rewrite it. So Q1 is, where's Q1? 58 times 1.5. That's not true. Minus 1.5 times IQR, which is 25. Okay, 58. Take away 1.5 times 25. That equals to 20.5. Now the bigger one, 83 plus 1.5 times IQR. 83 83 plus 1.5 times 25, that's 120.5. And there we go. Do we have any number that is smaller than 20.5? No. Do we have any number that is greater than 120.5? Also no. So there's no outliers. That's good. There's no outliers. Actually, you can kind of tell from the graph, which is the box plot, the box whisker plot. The box whisker plot does not really have a long tail by any end. Like on both end, the tail is not that long. So kind of indicate there will not be any outlier. All right, let's calculate the next section. Percentile corresponds to 63. Percentile correspond to 63. We will use the formula. The number of data entries, less than x over the total number of data entries. And then we'll multiply this number by 100. The number of data entries less than x divided by the total number and multiply by 100. So let's see, we're looking for 63, right? 63. Let me change the color, which is right here. Let's see how many numbers are smaller than that. We have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 numbers. Total, there are 30 numbers. And let's multiply by 100. Let me calculate that. 8 divided by 30, that will be 26.666. So let's say it's 27th percentile. 27th percentile. All right, last question. Which scores are below 25th percentile? We find the first quartile, right? The first quartile is 58. So all the number below 58 will be below 25th percentile, if it makes sense, right? So we'll state number 31, 41, 45, 48, 52, 55, 56. All those numbers are below 55, which is the first quartile. We'll say all those numbers are below the 25th percentile. Because before the first quartile is 25%. Between first and second quartile, between Q1 and Q2 is another 25%, right? Q2 to Q3 is 25%. Q3 to maximum is another 25%. That's why we divide all the data set into 4 equal parts by 3 quartiles. This is a question about the precision. Covers a lot of details. Play well good. Next one. The coefficient of variation. This question. In order to get coefficient of variation. So at first, we will need to know how to find out variance and standard deviation. Variance and standard deviation first. If you know how to do that, we'll just have one more step, that is coefficient of variation, that is sigma over mu multiplied by 100%. Okay, we just see the percent, the standard deviation as a percent for the mean. Yeah, let me just quickly solve those two questions. All right, for age, let's find mean first. Mu is 24 plus 29 plus 37 plus 24 divided by 4. What that is? 29 plus 30, click run, plus 37 plus 24, and divide by 4, we have 28.5 for height. Mu age, mu height, have 72 plus 76 plus 73 plus 76, and then divide by 4, we have 74.25. Can we round those numbers? I mean, I just really want it to be easy calculation for me. Ooh, all the way to, okay, I'm listing my table to calculate the variance and the standard deviation. Okay, for age, we have all those x's listed here. I'm gonna take away 29. Gonna take away 29. Now actually the sum of deviation is not 0 because we round up the mean. Otherwise it will balance back to 0. Okay. I just want to save some time to calculate here, but the idea is the same. Okay, squared every number. Take the sum of the squares. That will be 114. Again, let me know if I'm wrong. 114. Alright, so sigma squared will be 114 divided by 4. 114 divided by 4, that's 28.5. So sigma will be square root of 28.5. That's about 5.34. Okay, all those ones are for age. Now on to height. Now 72, 76, 73, 76. Okay, now those ones take away 74. Again, it's supposed to be balanced to 0, but not because we round them in. Okay, let's squares. So we have sum of the squares equals to 13. So sigma for height square, that is 13 divided by 4. What is 13 divided by 4? 3.25, and then we take a square root of the 3.25. So sigma for height is 1.8027 or something. All right, so coefficient of, let me change the color. So coefficient of variation for age, we will use 5.34 divided by the mean, which is 29, and multiply by 100%. So list after the calculation, 5.34 divided by 29, I get 18.41%. Okay, so coefficient of variation for height, I like to use, lost my pen again, 1.8 divided by the mean, which is 74, multiplied by 100%. That will be a way small number. Divided by 74. So I have 2.43%. Okay, so of course, by looking at those two coefficients of variation, we can conclude that the set height, what is it? Which one has more variation? Oh, age has more variation compared to the set height, or the height varies little compared to the age. So the age set is more spread out. The height set is more gathered together. Okay, I think that's the last question to the review sheet, but we have a couple graph questions to do. Just create with a separate sheet. All right, use the frequency to see the number of classes. We count the bars, right? 1, 2, 3, 4, 5, 6, 7. We have 7 bars. We have 7 classes. Estimate the frequency of the class with least frequency and greatest frequency. We are estimating frequencies, right? So the greatest frequency will be, I think, 23. Okay, so least frequency, I would say, is about to be 1 or 2, up to you how you're gonna estimate it. Class width. Class width can be the difference between two midpoints. I can use 125 to take away 72 to have 53. You can use any two pairs, okay? Any two pairs. You find the difference of the midpoints or the lower class limits or the upper class limits. I mean, either two lower limits or two upper limits or two midpoints. The difference is going to give you class width, right? It's still 53. That's for frequency histogram. Well, now the relative frequency histogram, only thing instead of frequency, we have relative frequency. Now the greatest, identify the class. We're not looking for what is the greatest relative frequency, right? Identify the class. Which class has the greatest frequency? The greatest relative frequency. We can say the third class. That's fine. Or we say the class with midpoint 19.5, which is here, and that's true. Either way, your answer is good. Either you answer the third class or say the class with midpoint of 19.5. Now, next one, approximate the greatest and least relative frequency. So the greatest one will be 40%. We can tell the least one is somewhere here. I'll say 2% or 3%, depending on how you're gonna estimate it. Okay, part 3, approximate the relative frequency of the third class. That's silly. We should ask the second class or something else. That's 40%, right? Okay, moving on. Frequency polygon. Okay, the dots graph. Number 1, dot connect to line graph. Identify class with the greatest and least frequency. Again, the same, right? We have the tallest, which is which class that is. Remember, we do not count the two set points. This is the first, second, third, fourth, fifth, sixth, seventh, eighth class. Those 2 points are additional points. When we graph, we extend the points to 0, right? So the greatest frequency occurs at the fourth class, or you say the class with midpoint 8.0. It's a little hard to say. Okay, and the least frequency is gonna be the first class. Okay, this has the least frequency, it has the greatest frequency. Now the number of classes I just marked, there are 8 of them. Class width. Class width will be the difference between two midpoints, right? Let's find two midpoints and see which two midpoints you like to use. And it does. Let's choose 3 and 4. 3 is right here. I think that's 7.5 because that's between 7 and 8. So we can use 8.0 to take away 7.5 to find the difference between the two midpoints. That will be a 0.5. So class width will be a 0.5. It's the difference between the two midpoints. All right, last question. OJIF. OJIF is a cumulative frequency graph. Number in the sample. For cumulative frequency, the very last cumulative frequency will match the sample size, right? So the last one to match the sample size, I will say that's a 50. Okay, and the location of the greatest increase, of course, on green, on the green part. Or you can say it's from 345.5 to 365.5, where that's the location for the greatest frequency, right? Okay, next one. Cumulative frequency for a weight of 345.5. 345.5, which is here. The cumulative frequency of this weight will be 15. Okay, the height for which the cumulative frequency is 35. We know the frequency, cumulative frequency is 35. Let's go get it. That will be 385.5, the weight of this pound. Should be weight, right? Okay, number of gorillas that between 325.5 and 365.5. Clean up, clean up. 325.5 to 365.5. Okay, how many numbers are between those two? Let's see where exactly this is at. So we know onto 365.5, let me estimate there are 32. So 32 of them are less than 365.5. Now 325.5, I will estimate that is about, what do you think, 6? Hey, so there are 6 of them are less than 325.5. 32 of them are less than 365.5. Okay, so what's the difference? I use 32, take away 6, we have 26. So there are 26 of them are between those 2 pounds. So this many total, this many less than, what's in between? We find the difference, right? Lastly, more than 405.5. More than 405.5. Okay, so on this number, I see the cumulative frequency is about 42. So there are 42 gorillas less than 405.5 pounds. So how many are greater than? Because we have 50 in total, right? And 42 are less than. What's the rest? The 8 of them. There are 8 gorillas the weight that is more than 405.5. All right, so that's the end of the page. That's the last page, last question. So we now finish the whole review sheet. I didn't make any stop or anything because you're on video. You can just pause and revisit at any point that you want. All right, feel free to email me if you have any more questions. All right, and that would be it. Bye.